So I wanted to talk about community testing of Lustre, and as this is one of the bottlenecks as Lustre continues to grow, um, and how to do this at your own site. So what we've been looking at is this is something that's come up is decentralized testing. So as we've seen over time, Lustre has become his, as you can see from the contributions this year, it's becoming a project now that's being used by several vendors, and vendors are actually contributing to the project. So it's becoming a much healthier ecosystem. Even though Wam Cloud DDN still does about half, that's much better than what it used to be, 80%, 85%. The same thing is happening. So the next thing is now is testing itself. So currently, while development is migrating away from being just Wam Cloud, testing is still done completely at Wam Cloud. It does everything. So, and currently Wam Cloud, their focus is CentOS 8, really, more than RHEL 8, servers and clients. So that's what they basically test. They do test lightweight testing, like Sanity and Sanity LNet testing for Ubuntu and SUSE clients and ARM clients. Their test matrix is incredibly large, actually, if you look at it. So they test to 2.12, they're going to be testing 2.15, they test the latest stuff. It's quite a lot of, it's a huge mess, and there's still users that do 2.5 and 2.10, so they actually have to keep track of all these issues. So what are some of the reasons why we consider doing this? Well, what really prompted ORNL to consider about this issue was the Red Hat CentOS issue. So CentOS is, as you know, they split, and there was this question, was CentOS going to go on a total different path from Red Hat? And because of that, we use Red Hat, and Livermore uses Red Hat, and we had this crisis where, like, is Wam Cloud going to abandon Red Hat and just go with CentOS? Because the reality is most of the user base is CentOS, not Red Hat. It's just overwhelmingly that. We are a very minority group. And this is still a real possibility in the future. Right now, it seems okay, but we don't know what the future holds with this commercialization. The other thing that has been progressing over time is there is a growing need for other platforms like Ubuntu and Ubuntu servers. People have been asking for that. And it's the same with ARM. ARM has been like this very lightweight tested, but Linaro has come forward and they said, we really need to have this really supported and well done. So they have, besides ORNL, they have actually looked at this problem as well. And they have actually nearly completed their own test cluster to set up for full reporting. So they're far ahead of what we were able to do. So they've done really great work on that. And this is the same with other second-class citizens. We have things like Ubuntu and Celeste, and we can actually, with the experience that we're going to gain from doing this, we'll be able to publish this information and make it available to other vendors and other places to be able to actually participate in this testing. Like, for example, we know that HP Cray does testing, but we never see the results of their testing. We just see the bug reports. But it would be nice if they had a properly centralized testing that would be fed into the Maloo centralized system, and we could see the results of their testing in real time. Note, this is all still a work in progress. None of this has been completed. There's been a lot of hurdles and bumps to get this to work, and also amount of basically cycles to do this. You look at it and you think, this should be an easy thing to do, but it's not an easy thing to do. So the first thing is, when you consider doing this, if you really want to participate, you have to consider the scale of the test system. So when you think about testing, you don't really realize how much work is needed to go into how much hardware and time is in the test systems. So when we look at Wam Cloud, we go, oh, why don't they test other things? We should really be more forgiving. Yeah, and when you do an analysis of what they're actually, how much hardware in that they throw behind this, it's enormous. So normally testing, like for your basic sanity testing, well, in our systems, this takes about 2.5 hours. It takes 36 hours to do full testing of everything. And that's just for LDiskFS. So a lot of times all these tests are duplicated for ZFS. So you have both ZFS and LDiskFS testing parallel sets done. So you're looking at 36 to 72 hours of testing. And that doesn't include, for those who are familiar with the test suite, there are slow tests which aren't even run. So if you've enabled them, you're going to double or triple that time to run a test. So for each test setup, you have some minimum requirements. So if you want to cover a lot of the tests, you need many OSTs, a lot of number of clients. You have to make sure you have a specific number, because some tests will not test if you only have 2 OSTs or 1 OST, 1 client. So I found that basically you can get about 8 nodes out of this, 8 VM instances, and then you double that for if you want to test both ZFS and LDiskFS simultaneously. So that's for each patch that's pushed. On a normal day, you get about 20 patches coming into Lustre. So if you do the math, you're going to see this is going to multiply drastically. So you're going to run up to about 160 VM testing instances to actually have a proper test suite to keep up with all the workload. You don't have to do that, but you're going to fall behind. And these VM instances are pretty hefty. You're going to need at least 256 gigabytes of memory and disk space on them, even more disk space, pseudo disk space, I would recommend for this testing. So you're looking at several hundred thousands of dollars of equipment to actually set up a testing system. So if you're really considering it, consider the cost. So what do you need to set this up once you have all your hardware in place? Well, you need Jenkins. So thankfully the Jenkins system is pretty standardized for Lustre. So it's your basic, you download the packages and it's Java based and you install it. I don't know how many here have done Jenkins before. I'm probably a good chunk of you have done it. And yeah, and there is a web page on the Wam Cloud site about setting up Jenkins, but it's from like RHEL 5. So it's quite outdated information. So once you have it installed, you have to create a Jenkins user with its home directory and you set up the password. And you should set up a .git config for that home directory with that username password, because you're going to be using Git checkouts with this for this build master. And then you have to unlock the Jenkins node with your web browser with an admin password. And then of course you have to use, this is all done with syscontrol. So you can check it out. Be very careful with firewalls. If you have strict security, you'll find out your Jenkins can't communicate with each other. So that's the basics, how to set up the master node. And then you have to set up your slaves. And your slaves, there's 2 ways you can set up your slaves. One is through the web interface. You can go to Manage Jenkins and Manage Nodes and New Nodes. And then there's this whole new form. You have to fill it out. I don't go over the details of that because there's a lot of that online, but you basically fill out the node names and who the master is and things like that. And then on the slave selection, you create the item, and they have something called a pipeline, and you add your pipeline script, which is basically the format. As I showed, you add the node, which is your slave node, and you have your stage, which is your build, and your stage, which is your testing. And in there, it runs your SH to your script that's used to build Lustre and to test Lustre. So those are basic ways to do it. There's another way to do it. You can run the Java on the slave jar directly for your slave agent. Now, for us, we have headless servers. So I have not figured out how to do the pipeline scripts with this approach. If anyone knows how to do that, I would love to know how to do that. So I have not been able to get any build instances going because there's not a GUI interface from our testbed to use very easily. So that's Jenkins. That's pretty basic. So as you know, everyone that's used Lustre has ever contributed, we know that it uses Garrett. And so Garrett is this nice setup. It's based on top of Git. Yeah, you configure Git for Wam Cloud. You have to set it up. There's the link how to use Garrett. So that's your first thing, is how to do it. Then you have to install Garrett Review. So on your favorite platform, whether it be RHEL or Ubuntu. And if you don't want to install it that way, you can also use pip, and you can install the Git Review that way, in case for those real hardcore Python people. And then you're going to have to configure your Git to be a global for the Git Review to your remote, and the username for your Git Review. So you have to create a special user for this. And then you can use Git Review-S in your tree once you have for Lustre, and you can see what it is. It's actually, there's a lot of options to Git Review. It's something worthwhile to explore in your spare time. So it seems pretty easy. Git Reviews on top of it, and you set it up. So now here comes the complicated part. So and that's the Wam Cloud setup. So Wam Cloud adds a lot of extras on top. So you're going to need Python and Python requests installed. And of course, you have to set up all your build environment for Lustre in your kernels and libraries. You have to check out the Garrett check of Lustre. And then you make sure that your Wam Cloud is a HTTP password for your Garrett account. And then you have to download it. Oleg has published a lot of his information, so he has a lot of little script magic to make this all work. So one of the things you need is like a Garrett authorization file. So if you look at his site there, you'll see there's an example of this, and you have to rename it, drop the example off, and put in your proper Garrett username and password so that you can check it out. There's that special account that you have to register with the Wam Cloud Garrett to get this account. And then, so you set that all up. And then there's, of course, Garrett built and the new test py and runbuild.sh. Those are various scripts to help you to put this all together, because you have to keep it in constant sync. So every time someone pushes a patch, you have to be able to be aware of that and update your own tree, and then spawn the Jenkins builds, and then also execute all the tests. So the funny thing about this is that run build has disappeared from the repositories. I don't know what happened to it. So I've been trying to figure out how to redo it. The instructions were that you were supposed to edit this file to point to your own kernels and Lustre source locations. Unfortunately, I haven't been able to find a copy of this. And then, of course, we have Garrett buildpath.py. This one is actually, you tell it where run build is to run it. And then you have to set the builder type. So you actually label what your tests are for. Say you want to test Ubuntu 22.04, you label it. And then you have to set the revision history to the current Unix time, which is that long number. And if you want to post your results in the script, there is a self.post enable. You have to set that to true. So besides what we've been trying to do, ARM has also set up their own test cluster. So ARM contribute these slides, which was very helpful, and they talked about how they set up theirs. So they actually told me, they said, actually you can leverage, if you get permission from Wam Cloud, you could actually leverage their Jenkins as well. So you could actually be a slave off of one of their master Jenkins servers. They have their own OpenStack cloud to provision for their test VM clusters and set up all their environments. And then they execute the tests with Oster locally. This is kind of how we do it. And then they have been trying to upload it to the Maloo database. Though you need a type of token key to be able to access that community database. That's being set up. That hasn't been completed yet. So they've actually put all their work and they've modified their own scripts based on the build scripts. And that's the link there on GitHub. So I've actually looked at it, and actually their own version of build run is actually nicer because it actually leverages the L build system within the Lustre tree. So I'm going to be exploring replacing that work with theirs. So currently they've been testing and building ARM jobs, and they've been testing all these much more extensive testing. And of course, this is for their server components as well. And so basically, this is basically what you have to do. So they do it once a day. They watch all the Wam Cloud Garrett changes. That's what I was telling you about. You have to actually, and that's the Garrett build patch PY. That's what that's used for, which I was talking about earlier, in the environmental variables you have to set up. So that just sits there and watches all day when changes come. And then from there, you have to trigger the build process, and then via the Jenkins slave. And then there's build release shell, which leverages the build system, which I was describing. So actually, it's a nice cleaner way. And then, of course, you move your RPMs to, they actually move their RPMs to the site for their external ARM repo. So all the RPMs they build constantly for every patch, you can go grab them. So it uses their OpenStack system for doing this. And it also configures the test environment. And of course, it's actually a nice system. I've never used Terraform, so I'm not familiar with it. I don't know if anyone here is. I'd be curious to see what people think of using that. So in their case, they're using 5 VMs in the OpenStack, and they're initializing the Lustre. So this is pretty much how the phases go. And as you can tell, like the Jenkins slave sets off with your pipeline scripts to run the node initialization phase and the test phase. And this is the steps they do to do that. And so all this work and research we've been doing into this has been provided by DOE. And thank you for that work and sponsoring it. And in the end, I'm hoping that once we sort this out, we're going to contribute to the Lustre tree itself, all the scripting in that. It should be in a proper place where if you download the source tree, you can actually perform out of the source tree all this setup and configuration. That's the long-term goal. Thank you.
Thank you, James. I have a question. So if you said it, do you have your own test infrastructure at Oak Ridge?
Yeah, we have our own test bed. Yes.
Do you know how many sites are doing Lustre tests and are connected to Maloo?
Absolutely zero right now, because everybody's trying to figure out how to do it. Okay. ARM is the closest to completing this work.
Great. Okay.
Yeah, we have been busy with it's a side project for us right now. It's not the highest priority. So.
I see. Okay, thanks. I don't see any question. If you have any questions for James, please use the on-air portal. I don't see any. So, well, thanks again, James, for this presentation. Testing is critical, I guess, for production.
We definitely need to share the work burden. It's an expensive proposition. That's the only thing is the cost. But if we want to support other things, we're going to have to do that.